video, we're going to take a closer look at how the shipping industry is starting to shift toward lower emission solutions. There are 140 ammonia-fueled vessels in various stages of development. Here we will focus on EXMAR's ammonia-powered vessels. EXMAR are the proud ship owners of the two world's first dual-fuel ammonia-powered mid-sized gas carriers, named Antwerpen and Arlen. We'll begin by understanding the scale of the challenge, then explore how these ships are designed to operate differently. From there, we'll look at the potential environmental impact, followed by the safety systems and training needed to support this transition. We'll also touch on the role of industry partners and what all of this could mean for the future of shipping. Shipping plays a massive role in our daily lives. Almost everything we use has, at some point, traveled by sea. However, this global system depends heavily on traditional fuels like heavy fuel oil and diesel. These fuels are reliable, but they also produce significant greenhouse gas emissions. These large ships generate roughly 3% of all GHG. Because ships travel long distances and operate continuously, batteries are simply not a workable solution. Today, there is increasing pressure from regulators, customers, and the public to find cleaner, more sustainable solutions without disrupting global trade. EXMAR is the largest independent ship owner in the mid-size gas carrier MGC segment for LPG and ammonia transport. Since receiving its first ammonia carrier in 1983, EXMAR has transported a cumulative total of over 100 million tons of ammonia. EXMAR is developing a new class of vessels designed to operate with ammonia as a primary fuel. These ships are built with dual fuel engines, meaning they can run on ammonia but also switch to conventional fuels if needed. This flexibility is important, especially during early adoption when fuel supply chains are still developing. The goal is not just to introduce a new fuel, but to do so in a way that maintains operational reliability. These vessels are expected to enter service in the very soon, marking one of the early real-world applications of ammonia in marine transport. One of the biggest advantages of ammonia is that it contains no carbon. This means that when it is used as a fuel, it does not produce carbon dioxide emissions. Additionally, ammonia can be produced using renewable energy. Ammonia is composed of one nitrogen molecule and 3 hydrogen. Green ammonia sources hydrogen from water electrolysis and nitrogen from the air. While ammonia offers clear environmental advantages, it also introduces different risks. As a liquid, it can corrode incompatible materials. When it evaporates, the gas is roughly as dangerous as carbon monoxide, so it creates risks in confined spaces. This means that it cannot simply replace existing fuels. Ships must be redesigned, crews must be trained, and safety systems must be enhanced. The transition is not just about adopting a cleaner fuel, it's about managing a different set of challenges responsibly. The key here is different. Ammonia has far lower risk of fire or explosion. Class societies have a lot of info on the dangers of existing fuel systems. Designs for ammonia fuel target overall risk levels below those of conventional fuels. Risk-based certification, RBC, is Lloyd's Register's process for managing the approval of novel vessel designs. This risk-based approach is used to demonstrate an equivalent level of safety to that achieved with conventional oil-fueled systems. EXMAR has transported over 100 million tons of ammonia. They have lots of experience safely handling ammonia. However, using it as fuel means it is now also in the engine compartment. To address the risks associated with ammonia, these vessels are equipped with multiple layers of safety systems. Double-walled piping helps prevent leaks, while gas detection systems continuously monitor for any signs of ammonia presence. Ventilation systems are designed to disperse gases safely, and emergency shutdown mechanisms can quickly isolate affected areas. These features work together to create a controlled and secure operating environment. Technology alone cannot ensure safety. People play a critical role. Crew members undergo specialized training to handle ammonia safely. This includes understanding its properties, using protective equipment, and responding effectively in emergency situations. Regular drills and simulations help reinforce these skills, ensuring that crew members can act quickly and confidently. Training is ongoing, reflecting the importance of maintaining high safety standards at all times. The safe adoption of ammonia as a marine fuel requires collaboration across multiple stakeholders. Ports must be equipped to handle ammonia safely, while classification societies ensure that vessel designs meet strict standards. Regulators develop and enforce policies that guide safe operations. EXMAR is taking an active role. They developed a safety training program and they are using it to train other companies. In partnership with Lloyd's Register and the Belgian Federal Public Service, EXMAR helped develop guidelines for the safe use of ammonia cargo as fuel on ammonia carriers. These partnerships help create a consistent safety framework. The use of ammonia as fuel is still in its early days. There are many challenges to address, including infrastructure development. For example, ships need refueling facilities. However, initiatives like this represent important progress. They show that the industry is investing in solutions. One of the biggest challenges in adopting ammonia as a fuel is infrastructure. Unlike traditional fuels, ammonia is not yet widely available at ports around the world. This means that significant investment is needed to develop storage, handling, and distribution systems. Coordination across the supply chain is also essential, from production to delivery. Addressing these challenges will be critical to scaling up the use of ammonia in the shipping industry. As we've seen, the adoption of ammonia is more complex than simply changing the fuel in the tank. It brings real opportunities to reduce emissions, but it also demands that we revisit how systems are designed, how crews are trained, and how partners collaborate. This will not happen overnight, but efforts like these show that the industry is moving carefully but intentionally toward a more sustainable future. In the end, progress in shipping will not be defined by how fast change happens, but by how well it is managed.